Hi guys, my name is Peter C. Dogba Jr., math instructor at the University of Liberia and your math tutor. In my today's lesson, I will be looking at a differential equation, and I'll be teaching you how to solve a differential equation using variable separable method. And in previous lessons, we did a few problems, like up to 12 problems, and we want to do additional 2 more problems, so that you have a broader understanding of how to apply the method of variable separable. Now, we told you that in order to apply variable separable method, it means that you must be able to separate the variables within a differential equation. Then you can apply that method. So if you have a differential equation where you can put all x one side of the equation and all y expressions on the other side of the equation, it means that you can apply variable separable method by integrating both sides of the equation after the variables have been separated. So let's do this problem and then we do this other one. So we have dy by dx plus the square root of 1 minus y squared divided by 1 minus x squared equals to 0. So the first thing we need to do is that we need to separate this. We know that the square root of a over b is equal to the square root of a all over the square root of b. So we can separate this. Now we have dy by dx plus the root of 1 minus y squared all over the root of 1 minus s squared equals to 0. So now we also want to get rid of these two denominators. So we can find one way is that to find the LCD, or another way is to multiply this entire thing by these two denominators. So we can multiply this by dx and also by the square root of 1 minus s squared, right? So I'm going to put this, I'm going to put the dx last. Okay, so dx. So we're going to multiply this whole expression by this. So this times this first term, this numerator, right, dy. So you'll be left with dy and this expression because dx and dx will cancel. So we have the root of 1 minus x squared dy plus. So if you multiply this and this, it means this root will cancel this root. So you just be left with the root of 1 minus y squared times dx equals to 0. So now what we need is that we want to ensure that all of the expression, now if you look under this radical, every expression in here is like x, you know, in x. So everything here is y. So we can make sure that all those terms with y on one side and all the terms with x on one side. So now this can be placed on one side, and then this is maintained on this side of the equation. I want to maintain dy because probably at the end of the day I will want to solve for y, so I can maintain dy on this side of the equation, and then I send this one across. It becomes minus the root of 1 minus y squared dx. So my concentration is actually this dy and this dx. So since I have the x here, it means that whatever that should be in here should be x. So this is not. So I can divide both sides. 1 minus y squared. 1 minus y squared. Likewise with this is y. So everything here must be in y. So I must get rid of this one. 1 minus s squared. 1 minus s squared. So this, we cancel this one. This will cancel this. We'll be left with dy all over the root of 1 minus y squared equals negative dx all over the root of 1 minus s squared. Now, since the variables now have been separated, we can integrate both sides. Now, the integral of dy by 1, dy divided by 1, the square root of 1 minus y squared is just equal to sine inverse of y equals also the integral of, now if we take this negative and put this negative in there, so the integral of, like saying -1 all over the root of 1 minus s squared dx is just equal to cos inverse of x plus some arbitrary constant c, right? So that's how we find the derivative of it. So you just need for us to simplify it now. We just need to simplify it. So we can solve for y. So we can solve for y by bringing in the property of, we know that sine inverse of x is equal to x. We also know that sine inverse of sine of x is equal to x as well. So you can try on your own, put values of angles here, and just say sine inverse of that angle will give you that same angle. So now we can, since we want to solve for y, we can say sine inverse of y, which will now give us y for the left hand side, equals, so we do the same thing on the right hand side, sine inverse, that's a sine of cos inverse of x plus c, and then this is just equal to sine of cos inverse of x plus c. So this is the general solution of this differential equation. So let's do the next one quickly. So the next one says x plus 1 dy by dx plus 1 equals to 2e raised to the power minus y. So again, we want to separate the variables. So we can send this one across. Now in here is just x and y, so no need to do further simplification in here. So it's just x plus 1. So it's all x. Now you have dy now by dx equals to 2e raised to the power minus y minus 1. We can cross multiply by multiplying this dx by this. So if you just do that, let's do that quickly. You just have dx, right? So the next thing we need to do now is to ensure that this x, we have all x, and this is, since it is dy, we must have all y. So it's not the case, so we must get rid of this x plus 1. Get rid of this x plus 1. And then also we do the same on this side, 2e raised to the power minus y minus 1. And then 2e raised to the power minus y minus 1. So this one we cancel this. This will cancel this. You have dy now all over 2e raised to the power minus y minus 1, right? And what next? Equals dx all over x plus 1. So now our goal is to ensure that we'll be able to integrate both sides, because we've already separated the expressions now. So we just need to integrate both sides. Now let's look right here. We can further simplify this one. So if we are to integrate both sides. If we further simplify this, you have dy all over 2 all over e raised to the power positive y minus 1. Because the power is negative, if we reciprocate, it's going to be positive. So that's what we did right here. Equals the integral of dx all over x plus 1 is just the ln of x plus 1. So for this case now, we can simplify it, dy all over. So we multiply, so it's 2 minus, this time this is e raised to the power y all over e raised to the power y. So what happens? This e raised to the power y can come in the numerator. So when it goes in the numerator, now you will have e raised to the power y dy all over 2 minus e raised to the power y equals to ln of x plus 1. So now we can apply the u substitution. So we say let u equals to 2 minus e raised to the power y. So we differentiate both sides, we will have negative e raised to the power y, because the derivative of e raised to the power y is e raised to the power y. So this is, so you have the integral of, now, because up in the numerator is just e raised to the power y dy, so we can say let's divide both sides by minus 1, minus 1. So you will have negative du to be equals e raised to the power y dy. So we see that it's almost done. So e raised to the power y dy is just equals negative du all over. This denominator now is just u, and the right hand side is just the ln of x plus 1. So this will just give us the ln of u equals to the ln of x plus 1, or equals, or let's say plus some arbitrary constant c. So you see that? So what do? Simple as it is. So we can, now, if you have our ln of a is just equals to ln of a raised to the power r. So this, the coefficient is 1. So we can take this minus 1 and raise it to this u. So it's ln of u raised to the power minus 1, or equals to ln of x plus 1 plus, now this c we can also rewrite it as ln of c, which is the same as a constant. So we further simplified, we have the ln of u, which is now 1 over u, equals, now the ln of a plus the ln of b is just equal to the ln of a times b. So this will be the ln of this times this one. So it's c times x plus 1. So what do we do now? We want to solve for this one. So we can first bring in u, the value for u, which we got was u was 2 minus e raised to the power y. So it's ln of 1 all over 2 minus e raised to the power y equals to the ln of c times x plus 1. So we also know that e raised to the ln of x is equals to x. So we can say let this be rewritten as e raised to ln of 1 all over 2 minus e raised to the power y equals, and then this e raised to ln of c times x plus 1. So e raised to ln of this expression is just equal to this expression. So it's just 1 all over 2 minus e raised to the power y equals. And the same thing with this is just equal to what is here. So you have c times x plus 1. So remember, we can still simplify it further to make e raised to the power y the subject and see how we can solve for y if it's possible. So we have 2 minus, we have 1 all over 2 minus e raised to the power y. But many books or many instructors want you to just stop as far as just right here. In fact, just right here, just replace u, and then you're done with your problem. So I'm just showing you more ways in which you can further simplify the problem if the need arises, So we have equal to c x plus 1. So now we can like cross multiply. Yes, cross multiply. So you have 2 minus e raised to the power y times c x plus 1, or equals to 1. Yeah, sure. So will be like a kind of difficult for us to solve. So multiply these expressions. So we can factor out c We factor out c, so we just have like 2 times this. So maybe we don't have to go that route. We just stop right there and say that's our answer. Because if we multiply again, we'll have like 2x plus 2 minus e raised to the power, let's say minus x e raised to the power y minus e raised to the power y equals to 1. So we just like have like 2 expressions for e to the power. So we don't need, no need to do that. No need. Yes, no need. So you can take this if you want to take it. E raised to the power y minus e raised to the power y equals to 1 over c. You can take it. So you can take this, or you just stop right there as your answer. You stop right there. Or if your teacher just wants you to not go too far, just you can just stop right there. You just stop right there, which is minus ln of u equals to ln of x plus 1 plus c. Most instructor will not even want to replace the c with some ln or stuff like that. They just want to leave it as it is. So you can just deal with this, and this, So you can say, let's say we have 0 on this side. We send this one across, it becomes ln of x plus 1 plus ln of u. So we know that u now is just, let's say we have 2 minus e raised to the power. So plus c. So we can deal with these two. So you have 0. Now, if 0 is equal to this, it means this is also equal to 0. So okay, we put the 0 on this side. So this and this is just like saying ln of this times this. So it's x plus 1 times 2 minus e raised to the power 1. Right? Plus c. So you can leave it like this, whatever way you want to do it. Or you can even send the c across and then you take e on both sides. It still gives you the same thing. So thanks ever so much for watching. Math is fun. Let's always have fun. Please subscribe to our YouTube channel. Please subscribe. And also, what you need to do is you need to click the notification button so that you get update on new uploads. Thank you. See you in our next lecture.